Hello and welcome back. In today's video we're going to take a look at the EV3 ultrasonic sensor. As you can see, I've got the sensor mounted on the front of the bot. The ultrasonic sensor works like the echolocation of a bat. What it does, it sends out a very high frequency sound wave. It hits an object and bounces back, and it's able to calculate the distance between the front of the sensor and whatever object is in front of it. It can detect distances anywhere from 1 centimeter to 250 centimeters, or if you're measuring in inches, it can measure from 1 inch to 99 inches. So that's a pretty wide range. In today's video, we're going to be measuring distances on this table, which is 4 foot in diameter. So that's going to be perfect for what we want to do today. Let's go ahead and step over to the table. I want to show you how to set up the sensor and do some preliminary measurements before we get into the software. On the brick, let's take a look at port view. We can scroll over to the right and choose port view from the menu, and it's going to recognize that we have an ultrasonic sensor plugged into port number 1. And you can see that we've got a live readout here of 12.6 centimeters. And I've got an object here I'm moving back and forth in front of the bot to show you that that's a live readout. It can get down to, like I said, 1 centimeter. You can see the object there in front coming into view. If we get a readout of 255 centimeters, then we know that an object is either too close or too far away to be seen or measured. Likewise, if I don't want to use centimeters, I can hit the center select button, scroll down and choose inches. I can do the same live readout using inches. And just to show you, you'll notice on your ultrasonic sensor there's a ridge here, and from the best I can tell, it measures the distance not from the front of the sensor, but from that edge right there molded into the sensor unit. I had my ruler out and did some measuring, and I think that's what this is showing us, is the distance from the object to this ridge right here on the actual sensor. So this is our live readout, and we're going to use that in just a minute to do some maneuvers on the table. I'm going to use the edges of the table and this Lego plate as a little barricade. So we'll write some programs to show off how the ultrasonic sensor works. One more thing I wanted to show you. In today's example, again, I've mounted that ultrasonic sensor so that the front of the sensor is even with the front of the bot. That way when I approach an object, it's going to be easy to measure because the sensor is flush with the front of the robot. So let's jump in the software and take a look at some programming options for the ultrasonic sensor.
Okay, so here we are in the Mindstorms EV3 software and a new program called Test Ultrasonic, and we're going to write a very basic program here to test this out. Before we do, I want you to notice in our port view panel over here that we still have our 2 large motors in ports A and B, and our medium-sized motor, our auxiliary motor, is in port C, and we now have showing the ultrasonic sensor in port 1. And that's showing that it's measuring in inches. If I click on that, I can choose to measure in centimeters as well. Now right now, the ultrasonic sensor is connected to my laptop and it's kind of staring off into space, so there's no object, and that's why it's showing maximum value of 255. If I were to just put my hand in front of it, you can see that that's actually a live readout now, and I can do the same thing with inches. If I move over to inches, 100.3 is the value that you're going to get when it doesn't detect any objects in front of it. If I put my hand in front of the sensor, it's going to show in inches, and it will measure to the nearest 1/10 of an inch. You can see there. And so let's write a simple program. What we want to do today is use the move tank block to move forward, and we're just going to turn those motors on. And again, I'm going to make sure that they're pointing to ports A and B, which they are. And I will move at 30% power. I don't want to go too fast for this first run. You remember from the other videos that when we turn motors on, that's just on indefinitely until they either run out of batteries, or until I turn it off at the brick, or it comes across a wait block. And that's what we're going to use next, is a wait block. And we're going to have it wait for the ultrasonic sensor. And we're going to use compare, and this is where we can choose do we want to read in centimeters or inches, and I'll go ahead and choose inches. And then what we're going to do is run the motors forward until we get less than 4 inches from an object. We don't want to run into the object, whether it's a wall or the little Lego barrier. So I want the bot to stop about 4 inches from the object, and once it measures 4 inches away, I'm going to have the motors turn off. So there we go, very basic program. It's going to move forward until the ultrasonic sensor shows less than 4 inches, and then it will stop the motors. So let's go ahead and send that program and see what happens.
Okay, so with that program loaded, what we're going to do is navigate over to the program and we're going to get ready to run it. I'm going to use this Lego plate as our barrier, and I'm hoping that the sensor is going to pick this up. I will scoot the bot back quite a bit, and what we're looking to do is run the bot, and hopefully it's going to stop 4 inches before it hits that plate. So let's get ready to run it and see what happens. Excellent. So we're taking a look at this distance here, and we're going to hope that that's 4 inches. And I brought my tape measure, and we're going to line that up here. And it's looking like from the very front of the sensor, it's 3 inches and closer to 3.5 inches at the ridge here. I'm going to run it again, maybe a little bit different angle, and see if we get different results this time. Okay, so we measure from here again, and it's about the same. We're showing 3 inches from the very front edge of the sensor and 3.5 inches to the ridge there on the sensor body. So the spec sheet for this sensor tells me that it's accurate within 1 centimeter, which I interpret give or take a ½ inch. So we're in the ballpark. Let's run this program with the bot facing the wall and see if we get different results. Okay, so I've repositioned the bot and the table. Now you can see along here that we've got the edge of the arena showing, and the edge here is a piece of wood that's pretty tall, so we'll see if we get different results. I'm going to go ahead and run the bot. And let's get out the tape measure. And that's showing about 3.5 inches from the front edge of the sensor, and about just over 3.5, maybe 3 3/4 inches to that ridge there. So we can see that while it's close, it's not always going to be exact, but I think it'll work well for a lot of applications. So let's go try another program.
Okay, so we ran the first program with inches, and for the next program I'm going to change that over to centimeters just so we can see the difference in the readout. And what we'll do is keep the less than indicator the same, and we'll move it to 10 centimeters. So we're going to run the bot until we get less than 10 centimeters from the wall, and then we're going to stop the motors. Then we're going to measure in a little bit different way. I'm going to add on here another move tank, which is going to be on, and in this case the values for power are going to be -30. And what we'll do is back up from the wall. We've just stopped 10 centimeters short of the wall, and what we'll do is back up until we're 20 centimeters from the wall. So I have this moving back. Here's the weight block, and this time we're going to look for change, and we're looking for change in centimeters, and we're looking for the number to increase because we're going to be moving away from the wall, which will increase the distance another 10 centimeters. So this is a different use of the same weight block. Here we're using the compare option, and here we're using the change option. So when we're comparing, we're looking for a number greater than or less than. But when we're looking for change, we're looking for an increase or decrease. So in this case, the new part of the program is looking for an increase of 10 centimeters before the motors stop. So I'm going to go ahead and finish out this program with off for the 2 motors, A and B. So let's send this and see how that works.
Okay, so we just programmed version 2, which is for the motors to turn on, move forward until the distance to the barrier is less than 10 centimeters. Then we're going to stop the motors and move back until the distance from the barrier increases by 10 centimeters. So basically we're looking for a forward move and then a stop at 10 centimeters, back for an additional 10 centimeters. So let's take a look and see how it works. Okay, great. Okay, so I'm going to set this up at a different angle just to make sure everything tests out okay. I'm going to let it run a little bit further on the front end of the program before the weight block kicks in. And there you go. Worked out great. Let's try it one more time from a different angle and run. Okay, excellent. Just as another way of testing it, I want to start out the bot where I know that the distance is less than 10 centimeters, and we'll see if we get any forward motion at all before it starts backing up. Okay, so did you see that? If we start the bot where the distance is less than 10 centimeters, it will instantly jump over that part of the program and start moving back until that increases by 10 centimeters. Let's try it again. And there you go. Okay, so let's jump back into the software and try something else.
Okay, so our first two programs worked pretty well. I'm pretty much going to want to start over and try something new. So I'm going to get rid of everything after these first two blocks. And here's what I'd like to try. I want the bot to move forward at a pretty fast rate, but when it gets closer and closer to an object, it slows down and slows down, so it approaches it very cautiously. So in this first motor block, I'm going to choose to move forward at power of 60, and I want to approach that object at that speed until we get within 10 inches of the object. And once this value is less than 10, I want to change the motor speed. So I'm going to come in here, and instead of 60, I want to start moving at power of 30. I'll turn that on until we get to 5 inches. So I'm going to wait until this value is less than 5 inches. And then we're going to slow down the power even more to 15 power until we get within 4 inches. I'll change this value to less than 4. And then last but not least, we're going to slow down even more with another move tank block, and in this case we're going to slow it down to 10% power, and we'll go to measure anything less than 2 inches. And then once it gets within 2 inches of an object, we want it to go ahead and stop. So we turn those motors off. So we have a series of power decreases. We're going to go at power 60 until 10 inches. Then we're going to go power of 30 until 5 inches. Then we try power 15 at 4 inches and power 10 until we get to 2 inches, and then we break the motors. So let's go ahead and send that program and try that.
Okay, so here we are for our third program. I'm going to place the robot right here, and we're going to move to the right. You can see the edge of the table here, so this is what we're measuring against. I will start the program, and let's see how this works. As you can see, the closer it got to the edge here, the slower it went. Let's move it back so you can see it again. Here we go. And I'm going to grab the tape measure, and let's put a ruler to it. And I'm measuring exactly 2 inches to this ridge point here from the wall. So that's actually pretty accurate. I'll just flip this around. I'm going to use our barrier here. Let me get that in the shot, and we'll see how this works. Let's run it. Okay, as you can see, the accuracy isn't nearly as close on this, but we've got less than half an inch here. So I'm going to run it back and we'll try that again to see what happened. I'm going to move that over just a little bit more and run it again. Okay, and so with the tape measure, I've got closer to 1.5 inches. What I'd like for you to explore as you think about the discrepancies in those measurements is the area that the ultrasonic sensor is seeing and how the size of the object compares. Will it see an object this small, or would it even see an object this small? Or do we need something larger in place, or will it see it something off to the side? So as you build different programs, I'd also like you to experiment with different size objects and try to determine the different fields of view that the ultrasonic sensor uses to measure the distance. So good luck and happy programming.